Here's another problem which explores this idea of average speed. And again, this is one of those topics that, from my experience, a lot of students find difficult to get their head around. So let's actually look at the question and let's talk about a few theoretical aspects as well. This that you see here is the kind of question that you can probably see in physics if you're a high school student or if you're even a first year engineering or physics student in some university. So we're dealing with a car that drives from one city to another. So let's actually draw something out. So we have a distance which is split in a couple of sections, but let's say the initial city is A and then the car arrives at point B. Okay, so the car travels half of the distance with a speed of v1, which is 60 kilometers per hour. So half of the distance means that there's a point, let's call it C, which is right in the middle, and until that point C, the car travels with a constant speed of 60 kilometers per hour. Actually, I'm not gonna write any numbers here because it's gonna clutter the drawing. So the remaining half of the distance is traveled such that half of the time is traveled with a speed of v2 and the other half of the time the car travels with this other speed v3. Okay, so let's try to get our heads around this. So AC is traveled with speed v1, which is constant. Now, this other distance from C to B is traveled such that for half of the time, not for half of the distance, so it's not that until this point, which is in between C and B, the car travels with V2 and then with V3. That's not what the question says. The question says there is a point, we don't know where distance-wise, but what we know is that the time taken from C to D, which let's call it T prime, is the same as the time taken from D to B, which is also T prime. Okay, so the time taken or the time traveled with V2 is the same as the time traveled with V3. So V2 is here, which is smaller, which is 50, and then this one is V3, which is 80. Okay, so that's what's going on. And the question is, calculate the average speed of the car for the entire distance. First of all, the average distance, sorry, not the average distance, the average speed is not equal to this. So you can't just add up the speeds, divide that by 3, because there are 3 speeds. And let's actually see what we would get. So 60 plus 50 plus 80 over 3. Okay, so this is 190 over 3, which should be something like 60 something. Yeah, so this is something like 63.3 kilometers per hour. This is the wrong answer. It's the wrong answer not just because the final answer is wrong, but because the way in which we got there is wrong. So this is not how the average speed is defined. So the definition, the basic definition of average speed is simply that of AB, which is the total distance, divided by the total time. That's it. So let's look at things in a slightly different way. And hopefully that will let us understand this idea of average speed a bit better. So let's say that in the same time that the blue car leaves point A, there is another car, which let's color it with red, that starts traveling with this constant speed of v bar. Okay, so at time equals 0, we have the car in the problem that starts traveling from A, but we also have an imaginary car, which is our red car, which travels from A to B with the same speed all the way through. So the question is, what should this speed be so that the red car and the blue car arrive at B in the same time? And once we find this value of the speed which makes that possible, that is actually the definition of average speed, which is also given by this formula. Okay, so it's the total distance from A to B over the total time that it takes the blue car to travel from A to B. Right. Now let's say that the distance from A to C, let's give it a name, let's call it lowercase d, which is the same, by the way, as the distance from C to B, because C is right in the middle, right? So we have d and then we have d again. And let's also say that, let's call the time that the car takes from A to C as TAC, like this. So let's use this formula to start trying to find out what V bar is. So V bar is AB over the total time. AB is made up of two equal sections, which we called lowercase d. So let's write that as 2d over, and then we have the total time. So the total time is made up of the time taken to travel from A to C, which is just TAC, plus the time taken from C to B, right? That should make sense. Now, the time taken from C to B, the question tells us that we can think of it as being split in two equal times, and both times are traveled with V2 and then V3. So what I'll then say is that the total time is TAC plus 2 times T prime. So the numerator gives us the total distance, the denominator gives us the total time. Okay, so we've got 2d divided by, now the time traveled from A to C, think about it, the car travels with constant speed between A and C, which is this v1. So the time taken from A to C is the distance d over the velocity v1 plus, and then we've got 2. And for t prime, what I'll do, although you can do this in a couple of ways, I'll express t prime as just cd over v2. So what I'm doing basically, I'm looking at this section. So this section has a length of cd, which we don't know, but we know that's traveled by the car with a constant speed v2. So the time taken to travel that is distance over velocity. So 2 cd over v2. Okay. Now, the other thing to note, and the other thing we'll use as an equation, is the fact that this time and this time are equal to each other. That's what the question is telling us. So let's maybe use it. So first of all, I'll write the obvious t prime is equal to t prime. The first t prime is cd over v2. The second t prime is this other distance, db over v3. But the two fractions are equal to each other. And another thing I'll write is, instead of writing dB, we know that CD and dB together, they add up to this lowercase d that we called our distance as. So instead of dB, I'll replace dB with lowercase d minus CD. Right? Because dB is d minus this CD that we have here. Okay, so the reason I wrote it like this is because I wanted to get an expression for CD out of it in terms of lowercase d. So let's work out the maths here. So we have the first fraction, which is CD over V2 equals to d over V3 minus CD over V3. And then what we can do is I will put the CDs on one side, so I'll factorize CD times 1 over V2 plus 1 over V3, and that's equal to D over V3. Okay, so let's amplify this fraction by V3 and this one by V2, and we'll end up with CD times V2 plus V3 over V2 V3, and this is going to be D over V3. We can cancel some stuff out, so we can cancel out the V3s, and then we have CD equals to D times V2 over V2 plus V3. So this is nice. We just express the distance from C to D, which is unknown, in terms of D, which is also an unknown if you think about it, but it will work out in the end, as we'll see in a second, as well as the ratio between V2 and the sum of V2 and V3. So what did we do that for? Well, now we can go back here into this equation for average speed and write average speed as follows. So average speed equals 2D divided by, so we had, I think, d over v1 plus 2cd, actually, I'll just copy it for now. So 2cd over v2. So let me move this to the next page and we'll do the substitution here. So this is 2d over d over v1 plus 2 divided by v2. And instead of cd, now I'm going to replace cd with what we found cd to be in terms of d, which is d v2 over v2 plus v3. Make sure if I copy this properly. Yeah, that looks v2 over v2 plus v3. And then we have another cancellation, which is this. And we have another cancellation. So you can see that all the d's, well, we have a d in each term, basically. So we can cancel out this d, and this d. And we got an expression for average speed, which just has things that we know. So we know v1, we know v2, we know v3. So this is 2 over v2 plus v3. So all that's left, although you can calculate the answer as it is, but what I'll do here is I'll tidy this up a bit, just turn it into one single fraction. So this is 2 over. So in the denominator we have, again, I'm going to amplify this by v2 plus v3. I'm going to amplify this by v1. So this is v2 plus v3 plus 2v1 over v1, v2 plus v3, which is, if you invert the bottom fraction, that should be 2v1, v2 plus v3 over, and then we have 2v1 plus v2 plus v3, and that is how the final answer looks like in terms of the variables. Okay, so we haven't used any numbers yet, but we can do this now. So we have v1, v2, v3 as 60, 50, and 80. So we have 2 times 60 multiplied with 50 plus 80, which is 130. And then this is divided by 2v1, which is 120, plus 50 plus 80. Right, so let's see what we get in the end. So 2 times 60 times 1/3. I'll just leave it like this for now, just to see if anything simplifies with the denominator. So this is 120 plus 50 is 170 plus 80. This is 250. So we can cancel out a 0 like this. And we can cancel out a 5. So this is 25. You get 5. You cancel out with the 16. You get 12. So you end up with 2 times 12 times 30 over 5. And if you do the math, you'll get that this is equal to 62.4 kilometers per hour. And that's the average speed. And that's the correct way, the proper way to find the average speed. So again, what the significance of this v bar is that, again, in the same time that the blue car leaves from point A, I have my imaginary car, my imaginary red car that starts from A with a speed of 62.4 kilometers per hour. So if my red car has a constant speed of 62.4 kilometers per hour, and if it starts from A in the same time as the blue car, it will arrive at point B in the same time as the blue car. Okay? And that's the end of the question.